Do you know why Python is embraced by VLSI? Do you know how to write the Hello World program in Python? Do you know the domains of VLSI which uses Python? Stay tuned till the end of the video to know all the answers. Hey guys, welcome back to the first episode of Python in VLSI. In today's episode, we are going to discuss the below points. First, we will talk about why VLSI adopted the Python. So we will talk about the reasons that are existing in today's VLSI industry that triggered the engineers to include Python. Next, we will talk about where Python is used in VLSI. We know Python is used in VLSI. However, we will go in detail the areas where the Python is used. Next, we will start deep diving by invoking the interactive interpreter. Next, we will give you the Hello World script in Python in two different ways. Next, we will talk about the comments that helps the VLSI engineers to segregate different part of the code and write the description of that particular part to the comments. And hence, we will talk about single line comment as well as multi-line comments. Next, we will go for the list of reserved keywords so that at very beginning, you know all of these keywords are reserved in Python and you cannot use them anyhow in your own variable declaration. Hence, we will conclude our episode. So that's the menu for today. Without any further delay, let's begin. Why VLSI adopted Python? That means why VLSI engineers prefer to use Python. Python is a powerful programming that combines remarkable power with very clear syntax. By birth, the Python is an object-oriented language. Like you know the difference, right? C is a procedure-oriented language, whereas C++ is a object-oriented. Similarly, the Perl is procedure-oriented by birth. However, you can do the object-oriented programming and we have episodes on that in the Perl playlist. In contrast, Python from birth is a object-oriented programming language and we can use its power for scripting in VLSI. Python is an interpreted, interactive, object-oriented programming language. So it's a scripting language. We can call it a programming language. However, it is not a compiled one. It's a interpreted one and hence it has an interactive shell. The reason of using the interpreted scripts in VLSI is that we don't spend time for the compilation and other things. We just write the script, check the syntax and semantics and everything is okay. Then we go for using that script. There is no point that you compile and generate a binary and then use it. No, there is nothing like that. So it's a very easy way. It incorporates modules, exceptions, dynamic typing, very high level dynamic data types and classes. So this is the inner resource of the Python that we have just pointed out. It has interfaces to many system calls and libraries and it is extensible to C or C++. So that is another part where generally the CAD people who are doing the automations in VLSI industry, basically a CAD engineer job role, those folks sometimes does have to use the proper software methods to assemble a large amount of scripts for a particular target goal by the design engineers. And that particular time you can have the benefits of Python. It is also usable as an extension language for applications that need a programmable interface through APIs. You know that Tickle is used to create APIs. Those APIs are used in the tool shell. Similarly, Python is used nowadays for many of the VLSI tools and flows. And it has a large library so that the APIs can be developed. And hence, versatility and the flexibility of Python is there. Finally, Python is portable. It runs on many Unix variants including Linux, macOS, and Windows. That means you write a script in Python, maybe on Windows, which is your home PC, and you can copy it onto your pen drive and take it in your office computer, where from using the Linux, and you port that into the Linux and you can use the code as is. So there will be no changes. So that is the portability factor among different operating systems. Python is very stable. So this is another important factor. If a scripting language or programming language is not stable, it is not going to help a production level engineering need. So the programming or the scripting language has to be very stable, and Python has it. New stable releases have been coming out every 16 to 18 months. Generally, based on the development phase, it is a regular interval which we get the Python releases. When I learned Python 2.7. Now this series, when I am broadcasting here, latest stable, I think it is 3.8. So we will learn here Python 3. There is a lot of syntax change among Python 2.7 versus Python 3. I'm not going in the benchmarking. However, in this series, we will focus on Python 3 coding. There are probably millions of Python users worldwide. So this is another thing. Python nowadays used vastly among vast application landscape. So that is not only limited to the VLSI. It can be anything. It could be an extension to a web browser. It could be something that needs to run on a web, something like that. So there is a lot of opportunities for the Python. So if you have a script written in Python, you may include something from the external already developed repository like GitHub. From there you can get something and you can include it readily. So that is the beauty of the Python. Enhancement requests are handled through Python enhancement proposals, and this is another good thing. So if you have a language where if you request something, that means something that is needed by you as a VLSI engineer and you are still not getting into any of the modules of the Python. So either you can write it, even when you are writing a module for your need, you are lagging something and that is not existing as an inherent property in Python. So you can request that to this particular enhancement request channel and get the results maybe in the proper release cycle, that is 6 to 18 months. So within that you will get it. So that is all the reasons that the VLSI adopted Python. We are done here in this slide. Let's move on to the next slide, where Python is used in VLSI. In this slide, we will talk about the Python applications in VLSI. Previously, we talked about the Python's basic characteristics because of which we choose Python in VLSI. And in this slide, we will talk about the areas of VLSI where the Python is. Obviously, this is not an exhaustive list. There can be many applications even beyond the things we are discussing in this slide. Please be open in your mind. Automating all steps such as compilation, elaboration, and simulation. Recently, we have published an episode on Makefile that is used as an inherent automation for these three steps. However, there can be scenarios where later needs are filled up by Python, and hence the everything, that is the automation of compilation, elaboration, and simulation, those are taken care by Python. There are many steps as well as PDK or DK dependencies which we can call through Python. We have an entire episode on PDK or DK, what is called. It's in the FAQ playlist. In case you don't know, please go ahead and watch it. Source code paths, environment variables, and tool path and licenses involved in compilation, elaboration till simulation. So there are a lot of complex things happening here. So a lot of things have to be preset in your terminal to do the desired software run for compilation, elaboration, and simulations. All those prerequisites can be well handled by the Python. It can be difficult to source them and redo it multiple times manually during the HDL design and primary test stage. For this reason, as well as some other reasons are there, why the Python is used in the front-end VLSI. So front-end guys love Python. They use it in a very extensive way. Next point is automating the code or test bench generations. It might be happening that you have a particular design series in your company and you want to generate the test bench. So Python routine has been written so that you can write that in a Python code how to generate the test bench, and there will be manual tweaks to that as per your design change. Those things can be well handled by the Python. Text parsing from log files or input or output or any file. This is a very important thing. When we run a tool, we generate a log file, and we have to carefully parse the log file for any warning or error or any other messages. It could be an info message also. That is very much relevant to a VLSI designer. All those things can be parsed and processed by the Python in very sharp manner. And here we talk about the input and output files. Many times the QA engineers do have to use the Python for doing the QA and QC, that is the quality check and quality analysis for the input and output files of any VLSI EDA tool. For that, Python is also used. append or modify some lines of many files with a single command. Generally, there are a lot of files here and there in different locations, and within that, for a particular set of design, you have to include one or more line in all of the files, which is corresponding to the design under consideration. So that automation, that modification can be done through a Python script. Python can be used for developing parameterized layout cells, that is Py cells, from PDK or DK. This is another thing. You can learn about the PDK and the DK from the FAQ playlist. We have an entire episode on that. Now, the Py cells are particular cells which are kind of unit cells in the PDK DK library. These are written in Python and they are scalable as they are parameterized. That means if we change the parameter, we change the different ratios of that particular cell, whether that could be height or whether that could be the number of inputs or whatever is there configurable through the Python module that has been used to define the Py cells. These can be configured across various technology nodes. So the Py cells may be written in a general format, and when we change our technology node, we can tweak some of the parameters and make the Py cells ready for another technology node. So that is the beauty of these cells, and here the Python is also used. So you must have a knowledge of Python to tweak these things. So not only front end as well as in the PDK DK, that is maybe in the back end or maybe in the IP generation case, that part of the VLSI also use the Python. So wide range of audience is there in VLSI who use the Python. We are done discussing this slide. Let's move on to the next slide. Invoking interactive interpreter. Generally, any of the scripting language has an interpreter that interprets line by line code of the Python. So here I will simply show you. However, in our entire course, we will use Python scripts rather than the interpreter, because interpreter, everything is volatile. In script, you can change in the script and then again you can source it and then you get the changed result. For interpreter, you have to write every line, and that is a very hectic for a VLSI engineer. So just for your knowledge, we will show you the interpreter here. And in our entire course we will use the scripts. This is my Linux prompt of my laptop, and here we type Python 3, and when we hit enter, these all lines are displayed. Let me clear it and show you again. So when we type Python 3 in our command line in the terminal of my laptop, this shows. So Python 3.810, and this is the time on Linux, and we have GCC this on Linux. These are the versions. Here it is giving some information and making the prompt ready. So here you can type any of the Python command and run it. And here while generating this, I tried to type exit. It doesn't take exit. Instead, it takes exit to exit the prompt. So this prompt will be terminated in your Linux terminal or Unix terminal by this exit command of Python. Or you can type Ctrl D. That is the thing. This is the way you can enter or exit in Python. In case you want to try out any single command, you can use it. However, as a VLSI engineer, you are trying at 5 o'clock in the evening and maybe 7 o'clock you are leaving the office, but in hurry, if you close the terminal, right, all the code is gone. So better you write a script and run. That we will show in subsequent slide how we are writing the scripts. An entire series we will use Python scripts, not the interpreter, but the interpreter works behind, and that actually process the Python code. The knowledge of the Python interpreter is a must for you, and that's why this slide is kept here. We are done discussing this. Let's move on to the next slide. Hello World in Python. So Hello World generally is the first program of any programming language that you come across, whether it is C, whether it is Perl, whether it is Tcl, or now we are in Python. So here is the simple code of the Hello World. First, you have to write #bang, then the path of the Python 3 binary. We will talk about Python 3 in this series. Hence, we will write Python 3 all along. So #bang, this is the path of the Python. You can get this using the command which in your Linux terminal, which Python 3. So that will result out this, and then you can copy this back in your text file. So here you are using a notepad or gvim, and next we write print, then within first bracket we write within the double quotes hello world. So this is the simple command, and when we are in our terminal, we save it in hello.py name. This is the name of the file, and we write /. That means in the executable, obviously we have to change the permission as a +x, chmod +x to this hello.py. So hello.py, when it is run, it gives the hello world output in the terminal. This is the one way of writing the Python. There is another alternative way of writing, and here it is. we write the first line as bang user bin environment. So to get this path, you have to type which env and it will get, and then we give a space here in between, and then we write Python 3, and then we write again the print hello world command. However, if we compare these two, I will prefer, and I will also ask you to prefer this one, because this is a straight call to the Python 3 interpreter rather than using first binary and then calling the second binary. This is the preferred way. Anyhow, there is no restriction. You can even use it if you want. And similarly here we have how we call it. Then we write Python 3 binary followed by hello.py. So here you can see the comparison here. Here is an extra effort that you are writing here Python 3, again you are using the Python 3 binary, then hello.py, and then you get the hello world output. So this is a much more short and sweet way of using the Python script. So in our entire series, we will prefer this method of using Python 3. Here we are done discussing the Hello World programming Python. This is a very simple program. You can go ahead and try it. I have an episode on Genie. It's in the FOSS playlist. Please watch that, because Genie is a very good IDE, that is the integrated development environment. There you can write the code in the upper half, and in the lower half there will be terminal and you can execute it. And then again you can change the code in the upper half and run the code in the lower half. So this is the very useful thing in Genie. Genie can be used for any programming language. So here we are done discussing. So let's move on to the next slide. Comments, how to. So here we'll talk about the comments. Now the comments is a very important thing in VLSI, because when you are writing a particular subroutine or you are a code block, what that code block does and where that is used and whatever versions of PDK that it implies to, all these information have to be logged onto the code, so that whoever the developer of the code rather than the developer, if any other engineer is looking into the code, he must or she must understand that particular message and interpret the next code block that is corresponding to that particular comment in a right way. So single and inline comments are done with the hash. Single line comment is like that. Here it is the single line comment, and if we have a Python code and after that we write a hash and then we do write something here, that will become the inline comment. So both are taken care by the hash. A bare hash, that means we don't have the ticks here, or it's I think the first quote. Okay, so bare hash symbol will do a single or inline comment, and in case of multi-line comment, it starts with I think 3 here. It's not a single, it's 3 double quotes, and then we have the text followed by the closing 3 double quotes. So for a multi-line comment, you can start the multi-line comments with 3. Remember, number is 3, and here it is number is 3. It's not 2 or 1. So it is 3. In between whatever lines are there, they will be treated as the multi-line comments. Multi-line comments can be written between triple double quotes and often used as a function and module comment. So which I just spoke about. As a VLSI engineer, you are developing a Python code for your company, and that code has to be interpreted or read by other engineers, and for those you have to pass on to some message, so that guys, this is a block that does this and this and takes these and these as the inputs and gives that and that as the output. All that messages can be put in a multi-line comment inside the Python script that you are writing for your company. So here we are done for the comments part. Let's move on to the next slide. The reserved keywords. So this is a very important. However, you may ask that why you keep these things we are not using, but you must be well knowledgeable what you cannot use. You should be well aware that what you can use, but you should be double aware what you cannot use. And here we will give you those examples. So you can see all these are keywords: false, none, true, and, as, assert, async, await, break, class, continue, def, del. So all these things are reserved keyword in Python, and you cannot use them as a variable or any function name or any module name or anything like that. And here it is elif, else, except, finally, for, from, global, if, import, in, is, lambda, non-local, not. All these are reserved keywords. And we complete the list here: or, pass, raise, return, try, while, with, yield. So all these are reserved in Python, and their purpose are there. You can get their purpose and operating instructions from the Python manual that is available in the Python site or Python documentation. Rather than it is called a documentation, not a manual. So you can use the documentation to understand all these keywords and their usage and restrictions. But for your custom code, you cannot name the code or name any module or any script's name as these words. All these words you cannot use for your custom naming. Rather than you can use them in your code as their usage is. There is no restriction, but you cannot use them as a custom naming of your script, of your module or function, anything that you are writing by yourself. So here we are done discussing for the reserved keywords. Let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.